Hello. In this video, we're going to go over graphing a rational function. When it comes to these types of problems, we have to make sure we understand and identify our intercepts and our vertical and horizontal asymptotes. After that, these problems become quite easy. So the first thing we need to do is find these intercepts for A. In order to find an intercept, so let's make an A over here. To find x-intercept, please set the numerator equal to 0. That's it. Intercept, set numerator equal to 0. Beautiful. So that's it. We're going to take 5x. Oops. Let's make it neat. We're going to take 5x minus 11. And we're going to move this down here because I know the camera gets in the way. So move it to the left a little bit. 5, we set the numerator straight equal to 0. We're going to solve now for x. 5x is equal to 11. Divide by 5. We see my x-intercept is 11.5 or 11.5 comma 0. Next, we're going to solve for the y-intercept. In order to solve to find y-intercept, we need to plug 0 into x and solve for y. That's it. So we're going to plug in 0 for x's. Every time you see an x, we're going to plug in a 0. And we're going to write down what is left. As you can see, this will no longer matter. We'll simplify this as negative 11 over negative 21, which is just equal to 11 over 21. So our y-intercept is 0, 11 over 21. So that's our x-intercept. This is our y-intercept. Beautiful. Okay, now that we have our intercepts, we're going to go over our asymptotes. So to find the vertical asymptote, we need to, I'm going to make sure those are visible t's. We need to set denominator equal to 0. So in this situation, we're going to have x squared plus 4x minus 21 equal to 0. We need to factor this with x method, right? So let's factor it very quickly. We have negative 21 on top, positive 4 on bottom over x over x. I see this can be plus 7 minus 3. We can rewrite it as x plus 7, x minus 3 is equal to 0. Separate them both. Solve them both. Then we have x equals negative 7 and x equals 3. These are the vertical asymptotes right here. Both of these right here. And in this situation now, we're going to go to negative 7 and draw a dotted line to represent our asymptote. And then go to positive 3. We're going to draw a dotted line to represent our asymptote. Next, we're going to look for the horizontal asymptote. Okay, so for the horizontal asymptote, what we need to do is look at the degrees at the bottom or the top. Well, both degree of numerator and denominator. So if degree of numerator, if the degree of numerator is greater than degree of denominator, which we rarely have, so we're not going to worry about that one. So when the degree of the numerator is equal to degree of denominator, let's move this over. Move this degree of denominator. What we have is we take the coefficients. And since we don't have that in this example, I'll just write a little example here. Let's say if it's y equals 5x squared minus 11 this time over x squared plus 4x minus 21. these both have the same degree as 2. So we take the coefficient of 5 and 1, and we say y is as the horizontal asymptote is 5 over 1, or just, y equals 5. So that is if what happens when the degree as the numerator is the same. But in this situation, the degree of our numerator is less than the degree of the denominator. And anytime this happens, since we have a degree of 1 on top, 2 on bottom, we know that my horizontal asymptote will always be y equals 0. So now we have our horizontal asymptote. We're going to put a dotted line there. And then all we need to do is take points on either side and then plug them into our XY coordinate plane. We can now answer the domain. So let's write down xint, answer A, which is 11, 5, 0, and the y intercept, which is 0, 11 over 21. So we can put those down. Our domain are the other values that don't include our vertical asymptote. So we're going from -infinity to -7, union -7 to 3, union 3 to infinity. We have a vertical asymptote at x equals -7 and x equals 3. We have a horizontal asymptote at y equals 0. So now we just have to graph it, and that is just plugging in points. So we need to, let's take green. We need to plug in points on either side of the asymptote. So this is -7. We're going to plug in -8 and -6. And we're going to plug them into our calculator. -8, I got -51 over 11, plugging that in. And -6, I got 41 over 9. So -6 is going to be a positive number up here. We know this sketch will be down here since we have to be below the horizontal asymptote and on the left of the vertical asymptote. And we know that value is negative, so we can plug that there. Next, we're going to plug in 2 and 4. 2 and 4. We get to 2. Also, this value is somewhere up here. We get to 2, it's 1 over 9. And we can see as I get closer and closer, if I do 2 point, right, if we plug in 2.5, we're getting closer and closer. This guy in here is going through. You have to plug in plug in 2.5, and you'll see we got our negative values. I didn't draw that really beautifully, but you get the gist. Let me just draw it better. You get the gist where it's like that. And then lastly, when we plug in 4, we get 9 over 11, a positive number. So we know we're on this part of the graph. And that's it. That is how you graph a rational function. Not the most fun things in the world, but pretty straightforward if you just do what we need to do. Our intercepts, our domains, and then our asymptotes, and then we just sketch the graph. If you have a specific question you'd like me to cover, please just send me an email. Other than that, I hope everyone has a great day.